Uh, yes, welcome to example 19 and the very last example in this unit and the topic. This is where Mechanic 1 ends. And the question is asking a particle P of weight 7 newtons is suspended in equilibrium by two light inextensible strings attached to P and to point A and B as the diagram shows. The line AB is horizontal. Find the tensions in the two strings. Well, we have come across something like this before when we are talking about static, and we calculated the tensions in different ways. And we are going to bring that knowledge to solve example 19. So there is this point A and this point B, and there's a particle P, which is at that particular point. Of course, the particle exerts some force downwards, which is 7 newtons. And well, there are two methods we can use to solve this question. For example, the first approach, we can shift the forces. Shifting the forces means we take this force the way it is and we bring it there. It's called the tension of A. And of course, you can see if that angle was 30 and is still 30, this is 40, 30, then this angle to complete the triangle was 180 minus the sum of this, which is 70. 180 minus 70, this angle was 110 degrees. Having shifted that force exactly the way it is, then this angle becomes 70 degrees. What we have to do now is to shift this force so that we can have our own triangle there. And how do we shift that force? If we can kind of extend it the way it is, then we need that angle when we bring this, the angle between the tension B to this force, when the line is produced straight up, this angle is supposed to be the one that comes here. And this angle, if this is 40 and this is supposed to be 90, then this is 50 degrees. So there is 50 degrees there. Of course, it goes without saying, if this is 70, this is 50, the sum is 120, then we have 60 degrees there. But anyway, we can also talk about this is 30, this is 90, and this part is 60. Exactly the part that shift there as well. So we have our new triangle. We have our new triangle that looks like, now we have this is the tension of B, and this is 7 newtons because it's the force that is going down, that is moving downwards. This is the tension of A. This is 70 degrees. This is 50 degrees, and this is 60 degrees. Having reduced our diagram that way, then we can easily solve it using any kind of approach that is appropriate here. But as you can see, if we can be able to use the SOHCAHTOA, because we have this 70 and the opposite side, we have the tension opposite to 50 degrees, and we have the tension of B opposite to 60 degrees, we can easily say that 7 over sine of 70 is given by the tension of A divided by the sine of 50. And if you use this, then we can make the tension of A the subject of the formula, which is 7 sine 50, everything divided by sine 70. We can easily do that. That is 7 times the sine of 50 degrees, everything divided by the sine of 70, and the answer is 5.71. So the tension of A is 5.71 newtons. In the same approach, we can still get the tension of B using the same kind of approach, and we can talk of 7 over the sine of 70. Please note that we can still use the tension of A, but because we have calculated ourselves, it is not advisable to use what you have calculated yourself. You might be wrong, and therefore you're going to transfer some mistakes to the next level of the question. So 7 over sine 70 is also going to be the tension of B over the sine of 60 degrees, making the tension of B the subject of the formula, 7 times the sine of 60, everything over the sine of 70 degrees. And the tension of B easily is realized to be 6.45 newtons. All these are to 3 significant figures. Having said that, I think it is important also to get the second approach. And the second approach is what we learned in static unit, because we can be able to talk about what about the reaction upwards or the total force upwards. If you consider this tension, it is not only pushing particle P to the left, it is also pushing particle P upwards through force, we call it Y1. So as you can see, we have, if we talk about the sine of 30 degrees, is going to be opposite, which we are calling Y1, over the hypotenuse, which we are calling the tension of A. And with this, Y1 is the tension of A multiplied by sine 30, and that is just Y1. If you consider this force again, it is not only pushing the particle to the right, it is also pushing the particle upwards with force, let's call it Y2. And as you can see, we can talk about the sine of 40 degrees, which is Y2 over the tension of B. And with this, you're going to have Y2 is equals to the tension of B multiplied by the sine of 40. Having said that, that is the total upward force, which must balance with the total downward force. So what do we say? Y1 plus Y2 is equals to the 7 newtons, the total force downwards, meaning that the tension of A, sine 30, plus the tension of B, sine 40, is equals to 7 newtons. That is the first equation of this particular arrangement. Again, if we would wish to consider the horizontal forces, then the tension of A is pushing the particle to the left through force X1, let's call it X1, and the tension of B is pushing the particle to the right through what we may call X2. And X1 is exactly equals to X2. But you can see this one is adjacent to the 30 degrees. That means if you talk about the cosine of 30 is going to be adjacent, opposite of adjacent rather, the SOHCAHTOA, the adjacent of hypotenuse, which means 1x1 over the tension of A, meaning that x1 is equals to tension of A cosine 30. And likewise, you'll find that x2 is equals to the tension of B cosine 40. Having said that, it is important to note that we can just talk about if TA cosine 30 is equals to TB cosine 40, then we can make TB the subject of the formula, which is going to be TB is equals to TA cosine 30, this is cosine 40 over cosine 40. If you use the calculator, then you will find this one could be cosine 30 divided by cosine 40 is going to be around 1.130 1.1305 TA, just because we have rounded off. If that is true, then TB has been able to be written in terms of the tension of A. That means what? We can go back and just write in equation 1, we can go back in equation 1 and substitute TB in terms of TA. So that means TA sine 30 is 0.5. That means we can have sine 30 0.5 TA plus, now the TB, we are going to, sine 40 is something else. So we'll have to have 1.1305, that is TB, 1.105 times sine 40, which is going to give us, if you substitute this one here, which is going to give us 0.72267, 0.72267 TA. All this is going to be 7 newtons as far as equation 1 is concerned. Of course, when you combine this now in terms of TA, you're going to have 667 TA is equals to 7 newtons. If you divide both sides by 1.2267, 1.22667, then you'll realize TA is going to be equals to around 5.71 Newton. If you compare this with what we got in the first method, then you'll realize that they are both equal. What about TB? But TB is equals to what? TB is equals to, as you can see here, TB is equals to something. There is somewhere we expressed TB in terms of TA. Where is that? TB. Where is TB? TB, after you just compare the two, you will find that TB is 6.45 newtons. And having said that, you can already substitute 1.1305 of TA, which we know to be 5.71. In fact, we can just use that. I've just found it there. So 1.1305 times TA, which is 5.71, 5.71 is going to give us 6.45 newtons. So either way, you will get home. And right, thank you. That is the end of Mechanics 1. And I wish you, all of you, best of luck, even as you revise and even during your exam. Thank you so much.